Here, when you determine where the quadrant, determine which quadrant the terminal side is in. So how many times you're spinning around. They're giving us a fraction, and we're gonna, it's what's called an improper fraction. So we're gonna switch it into a mixed number. How many times does 6 go into 1016? 1016 divided by what? 6. Thank you. So it goes into 169 times evenly. Now what's the remainder?
1/3.
1/3, right? You saw the 0.333, right? So this is 169 and 1/3 pi. So that's a mixed number. I'm changing it to the whole number and the fraction. How many of those pi are you going to use up every time you spin around the circle? 2, right? To go around the circle, the whole thing is using up 2 pi. So how many 2's fit into 169?
84.
So this is like 84 times 2, right? That uses up 168. So I still have 1 and 1/3 pi. It's kind of weird, I don't know, I shouldn't really write it this way, but my point is, we want that. So if you take your improper fraction, switch it into 169.3, divide that by 2, I have 84 times, right? So that's what we're looking at. So we need to figure out this. Where is that on the circle? 1 1/3 pi. So let's go back to our, well, you guys can go back and look or just draw it right here. This is 0 or 2 pi. This is pi over 2. This is pi. This is 3 pi over 2. So you have that on your first page. You can look at it there. Where does 1 1/3 put me on this thing? Well, third quadrant, you're saying?
Yeah.
So 1 1/3, is that more than a half? Is it more than 1?
No.
Is it more than 1 1/2?
No.
1 1/3 would be somewhere right here. So for this one, we can say the third quadrant, and I don't care if you say third quadrant or use Roman numerals for your third quadrant. Let's check negative 4 pi over 3. If you switch into the mixed number here, negative 4 pi over 3 would be negative 1 and 1/3 pi. Right? Negative 1 and 1/3. So I haven't even gone around once. So I don't need to worry about, dividing out the 2 and see how many times you spin around it. But we do have to make sure we go in the negative direction. So if I start at 0 and I come this way, is negative 1 1/3 more than a half? Now you have to be careful because we're going in the negative direction, so you can't really use my red numbers here. You have to kind of mirror image everything, so the 1/2 is down here. So negative half for this quadrant, negative 1 to here, keep going or stop? So I'd be somewhere around here. That's negative 1 1/3. Positive 1 1/3 took me from 0 all the way to the third quadrant, going in the positive direction, going the negative direction. What quadrant are we in? The second. Quadrant 2. How about 87 pi over 4. What's the mixed number for 87 pi over 4? 21 and what? And 3/4 pi. So in 21 and 3/4 pi, how many times can we spin around the circle? 10. We can go around 10, right? That'll take us to the 20 pi. So really, if I get rid of the 20 pi, 2 times 10, I'm only looking at 1 and 3/4 pi. So I'm going to wait for a second. I'll pause it, give you a second. Don't say anything out loud. Figure out where 1 and 3/4 pi is located on this thing. So where are we at? Fourth quadrant, quadrant 4. The I with the D, right? Fourth quadrant. Okay, so my question would be, is it really hard to figure out kind of that remainder? So the main thing is, in this first one we did 1 1/3 pi, and this one we did again negative 1 1/3. And this one I really was concentrating on the 1 3/4 pi. So what I'm working on is finding actually a coterminal angle that's somewhere on the circle, just one revolution, one way or the other. I don't want to spin around the unit circle 20 times, or 10 times, 20 times. That's a waste of our time. As long as you can figure out what that extra piece is, we ended up with 1 plus 3 divided by 4, right? So that's 1.75. Now, mathematically what we can do is get rid of pi. And remember that 2 pi goes all the way around the circle. So when I divide by 2, I'm about 87%, if you will, 87.5% of the whole circle. So if you think of the unit circle in quadrants and percentages, each quadrant represents how much? 25%. So the first quadrant is really represented with anything that's between 0 and 25%. Anything that's between 25 and 50. Third quadrant would be 50 to 75. And fourth quadrant is 75 to 100. So right there is your answer. I'm in between 75 and 100, therefore I'm in the fourth quadrant. Let's do the next one quickly. Negative 7 pi over 3. 3 goes into negative 7 how many times? 2 1/3, is that what I'm hearing? Okay. So this means we spun around the circle once in the negative, right? And I really only need to look at that, negative 1/3 pi. So you probably already know the answer. Or you can take negative 1 divided by 3, gives me that. I divide that by 2, and I'm at 16% in the negative direction. So that's staying in the first quadrant of the negative direction, right? Which is ultimately the fourth quadrant. Yes? For whatever reason, this vocabulary from geometry doesn't always carry through to now, but complementary is 90 degrees, supplementary is 180. Give me 2 angles that add up to 90, you're dealing with complementaries. Give me 2 angles that add up to 180, you're dealing with supplementary. So find the complement and supplement of each of these. Well, you always take your original angle and you subtract it from 90 or 180. So in this case, we would do pi over 2, remember that's 90 degrees, minus 4 pi over 5. Or you take pi, which is 180 degrees, minus 4 pi over 5. If you want to get common denominator, you go ahead and do that. 1 divided by 2 minus 4 divided by 5. Right? I wrote down pi over 2 minus 4/5. I get that. I go math, enter, enter. And I get negative 3 over 10, put pi back in there. That's complementary. If you do stuff out of the book will say there is no complementary to that. Because your given angle is already more than 90 degrees. Right? If something is more than 90, if you want to write down the negative, I don't care. If you want to say there is more than 90, go ahead and write. You do what you want to do. But mathematically, I can find it. It's negative 3 over 10. 1 minus 4 divide by 5. I get that. Math. Enter, enter. 1 pi over, what was it? Pi over 5?
Can you add the one you want to?
Say that again?
Can you add the one you want to pi?
Oh, yep. If you wrote 1, totally fine. So a lot of people just write the fraction down that the calculator gives them, put pi in the numerator. That's fine. Great. Do the next one on your own, write the answers down, check with somebody sitting near you, and then we'll take a look at them.
2. Give me a second. Or 5.
Like in this case, I would switch to 4 pi over 8 because that's the same as 1/2. And when you do that, 4 minus 1 is 3 pi over 8. So is that what you guys got on your calculator?
Yes, it is.
And then down here, the same thing as 1 would be 8 pi over 8, which would be 7 pi over 8. Good answers?
Yeah.
Seconds. Who's the science geek that knows what the circumference of the Earth is at the equator?
54.
How many miles? I think it's something like 26,000 roughly,
That's exactly right.
or 26,000 miles. So if you go to the equator, the circumference of the Earth is about 26,000 miles. Divide that by 60. 26,000 divided by 60 is what?
No, they don't know it yet. It's 50.
Excuse me. Sorry. Take the 26,000 miles and divide by
360.
360. Shh. 360.
72.
Right, 72. So the idea is, remember, lines of latitude create the ladder going up from pole to pole. Lines of longitude run from pole to pole. So they're the lines that arc from North Pole to South Pole, right? And they're 360 degrees of longitude all the way around. So when you get to the equator, the distance between those lines of longitude is 70-some miles, right? So when you think about GPS, if I can get you within 70 miles on the ocean, you're not really going to find me, right? So in between those lines of longitude, we're going to break each degree up into what we call a minute. So now if it's 70 miles, 1 minute represents approximately a mile. So if I say 320 degrees and 20 minutes, now at least you're within a mile of me, right? And then each mile can be broken into, or each minute I should say can be broken into seconds also, 60 seconds. So 1 degree equals 60 minutes, 1 minute equals 60 seconds. So that's why you see, on GPS it might be 320 degrees, 20 minutes, and 15 seconds. So we can get fairly close to you even at the equator of the Earth, let's say. All right, convert to decimal degrees. How much of a degree is 12 minutes?
12.
What's 12 divided by 60? 0.2, right? So this is 25.2 degrees. 128 degrees and 30 minutes. That's pretty easy because 30 minutes is how much of a degree? So this is negative 128.5 degrees. Now we're gonna go the other direction. 12.6 degrees. So when you think about this, and we convert it, I know we have 12 degrees, but I'm gonna take this 0.6. And what do I multiply by? I can just multiply by the 60, and what's 0.6 times 60? What's 60% of this next thing? What? So 36 out of 60 minutes represents 60% of a degree is what we're saying. So this is 36 minutes. 0.18 of a degree. So I can say 60 times 0.18. What do you get there? I get 10.8. So I have negative 184 degrees and 10 minutes. I still have 80% of a minute. What represents 80% of a minute? So I can take my 60 times 0.8, and what do you get here? So that's 48 seconds.